Hi everyone, my topic today is placement and location. Here is the introduction part of placement and location. In this part, I'll introduce the problem. The placement and location problem consists of following three factors. Endpoints need to be placed or located in R2 or R3 dimension, and some points are fixed and while others are free variables. And we will have corresponding cost function which is defined to be minimized. As we can see here in the figure, the square nodes are fixed while the black dots are free variables, which are our design variables. So our objective may be to minimize the length of the links between them. So this is the problem in my topic. We use xi to represent the position or location of each node in the figure, as we can see here. Where k equals 2 or k equals 3, that means we may deal with some problem in the 2D dimension or 3 dimension, and the problem is to minimize such a cost function. The A is the set of all links in the graph, and the Fij is the cost function associated with the link between xi and xj. So we want to minimize such cost. So the first part is the simplest part. It's called the linear felicity location problem. So we consider the simplest case. The cost for xi and xj is the distance between nodes xi and xj. Fij equals to, that is to say xij, Fij equals to the norm of xi minus xj, i.e. the objective is to minimize such a summation of the norms. We should notice here the norm is not determined, so we can use any form of norm. For example, we can use L1 or L2, even L infinity or LP norm. So in many cases, L1 norm is used because sometimes the design process requires either horizontal or vertical placement or location, such as in the circuit design. This kind of design is also called the Manhattan style because it's either horizontal or vertical. Here is a very simple example. It's called one free point. So we consider the case where only one point uv in the 2 dimension is free, and we want to minimize the sum of the distances to other points. So the objective function is in L1 norm. It can be written in this form. As we can see here, UI are fixed or known to us. So for example, we have 3 points, U1, V1, U2, V2, U3, V3, and our objective is to find a placement to put such a red spot and minimize the summation of the distance to these 3 known points. As we can see here, the solution here is very simple. It's just the median of these 3 points, known points, fixed points. And here we can also consider many different kinds of constraints while preserving the convexity of the problem. For example, as I mentioned in the previous slides, the squares shows the fixed points, and we impose some constraint that the black dots should be on a line. So as here, the dotted line is the